And for this one, we're given that our angle is between 180 and 270. So we know that that goes to quadrant number 3, right? Because here we have 0, 90, 180, and 270. Where 80 to 270, 180 and 270 is in this quadrant. And we discussed in the other video that this is how you model in that quadrant where this is the hypotenuse. Across the angle, you have your opposite. Process of elimination gives us the adjacent. And we are given sine, and we remember that SOHCAHTOA is a good way to memorize the 3 basic trig functions, where sine is opposite on top and hypotenuse in the bottom, where the hypotenuse is 5 and the opposite is -3. And if you go Pythagorean theorem, and of course you would make sure to put the 5 for C and the -3 for either AB, doesn't matter, you'll find that the missing leg is 4, but given that this problem has a context, and since the 4 goes to the left, it'd be negative. Now the diagram is complete, so we can move on to the goals. Now, I'll just do one of them, you can try the other ones. Let's say I try to find cosine of x over 2. So, cosine of x over 2, what does that equal? Well, let's see. Right here, we have a half angle. We have cosine, there it is right there. Cosine of x over 2 equals plus or minus. We have to decide if it's positive or negative. And I'll show you how to make that decision. But it's a square root, 1 plus cosine, that's like a regular cosine, over 2. So let's go back over here to our main paper. So we know that in the formula, it says plus or minus the square root 1 plus cosine x over 2. A quick piece of scratch work, we need cosine. Cosine is adjacent over hypotenuse if you think of SOHCAHTOA. So, and that is your angle. When it says x, it really just means theta right here, okay? It's this guy. So it's the adjacent over the hypotenuse. Based on SOHCAHTOA, cosine is adjacent over hypotenuse. So the adjacent is -4, and the hypotenuse is 5. Now this helps me because now cosine of x, which is here, is -4/5. So this is plus or minus 1 plus -4/5 over 2 plus or minus square root. If you clean up the stuff inside the radical, it'll be 1/10. And you can actually rationalize the denominator to get square root of 10 completely over a regular 10. Now the question is this positive or negative? This angle is not x. X is between 180 and 270. X is here, but this is x over 2. So what I do is I manipulate this equation to obtain some information. This inequality, this is called an inequality. I manipulate this inequality to gain some knowledge. Here's what I'm going to do. I'm going to divide every piece by 2. If I divide that by 2, it's 90. Divide that by 2, 135. Divide this by 2, x over 2. Why did I divide by 2? I divided by 2 so that it would say x over 2, which is the angle in question. Now, where is this angle? Where is that angle? Well, that angle is sandwiched between 90 and 135. Well, 90 is here, 135 is there. So our angle is somewhere just in a random spot here. And this is cosine. And this angle is in here, which means that in here, cosine is negative. And so this should be negative. I throw away the positive and I just say negative square root 10 over 10. So making the decision between positive and negative might require that you manipulate the original inequality so that it says the angle, usually a half angle, and then remembering the quadrants and who's positive, who's negative. If you want, we can just do that real quick before you go. So in quadrant 1, 2, 3, and 4, and we're talking about positivity, positive. So it turns out that in quadrant 1, you have all your functions are positive. They're all positive. In this one here, you have only sine is positive, only tangent is positive, only cosine is positive. So in quadrant 1, everyone's positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent. In quadrant 4, cosine. And sometimes people say this, maybe you've heard this before, all students take calculus. All students take calculus. This is a statement that helps us to memorize which functions are positive where. All students take calculus. So all of them are positive. And in here, only sine is positive. In here, only tangent is positive. And in here, only cosine is positive. Which means that the other two functions would be negative wherever they're not positive, right? So that's a good little way to memorize who's positive where. So a final answer for this one would be this. So now you should try these two right there.